So we've got a strategy with our traction control system that's a little different than most. Most traction control systems, their job is to stop wheels from spinning, right? Spin the floor, tires spin, it cuts the power and stops the tires with the brakes, right? Seems natural. Traction control, that's what it's for. We step back one step and think, well, wait, why'd you floor it? You want to go fast, right?
Yep.
Maybe you're turning left in front of a semi. Should we stop the tires from spinning? Is that noise really annoying? Or should you go? So our traction control strategy is to let the car do what the driver's asking them to do and try to limit the wheel spin a little bit. But we'll reduce the power a little bit, kind of let the tires catch up, drag the brakes just a hair, and leave a burnout mark every now and then, spin a tire. But you won't stall out in front of that semi.
Yep.
And that's kind of where our priority lies, is respecting what the driver is doing, right? And that works out great on the road. And then when we go to that trailhead, we start going up that really loose dirt road, and there's some big divots in the road, and your tire drops in a hole and starts spinning. Then that strategy doesn't work anymore, because we need a lot more brakes to stop that tire when it's spinning. So that's the thing that sort of triggered us to get a little more serious about how we handle our off-road, is that we were building cars that had ground clearance, but they would get stuck easily because our on-road strategy wasn't working off-road. So the first thing we do is we change the traction control strategy completely. Instead of reducing power a little bit, and applying brakes a little bit, we apply a lot of brakes. We stop that wheel from spinning, and we don't reduce the power at all, because you might be climbing up something really steep where you need all the power, right? So anytime you're in an all-wheel drive car, you spin one front tire, you're also going to spin one rear tire, because the drive goes to both ends, but then it goes through differentials and it can go to either side. So with the brakes, we can stop the ones that are up in the air. These dirt roads always develop these weird patterns in them, kind of like moguls on a ski hill, because an all-wheel drive car's gone up there before, spun one tire, spun the other tire, dug two holes, got itself out, and then you come up there and drive into the same two holes and take some more out, right? And so this stuff always just naturally occurs in a dirt road. So we built the system to handle those, apply enough brakes, and give you all the torque you can get up there. And then at the same time, the all-wheel drive system changes its strategy. Instead of trying not to waste fuel by not adding rear torque when it's not needed, if you put it in off-road mode, obviously you need it. So we start with it locked, so it doesn't spin the tire and then have to engage the rear tires while it's spinning. It starts off loaded and can have maximum traction in that situation. If you drive it on the road, it kind of feels drag. It shuts itself off pretty quickly if you do it. So we tried to be smart enough. That's the way we sort of try to make the car do what the driver wants it to do.
Side question, not related to the car. So you talking about like the moguls makes me think about like washboards.
Yeah.
Like on dirt roads. Why does that happen?
It's a natural frequency of the suspension of the cars that are driving over it, and so it's like a feedback thing where it starts making. You'll hit a bump and the wheel bounce a couple times and leave a mark in the road, and then the next car hits that bump and the marks it left after it, and it's driving at something at its natural frequency. And the cars all have natural frequencies that are close enough together that it's super annoying.
Interesting.
I don't have a spiel, so if you
that was
guys have any questions, bring them on.
Is there anything you want us to notice about the car? We're going to be recording an episode actually inside the cab of the car. Is there anything just about like how it's designed that we would notice when it's parked?
Well, hopefully,
are you asking where the podcast button is?
Yeah.
Off road, and then we're recording. The mics come out.
Hopefully, the first thing you'll notice is that it's quiet. That used to be a weak point of ours, because again, steering, handling, and NVH guys are fighting each other, and we always wanted our cars to handle really well, and sort of trying to elevate ourselves to the point where we can have the steering, handling, and have the car drive right, and still be quiet and comfortable, and recognizing how important that is. We've sort of expanded our performance envelope, and a lot of looking at sort of how people hear things, what frequency ranges matter to them, and how it actually affects people. One of the things we sort of figure out is that we're super sensitive to direction of sound, which means that if the sound does get into the car, and then reflect off the other window, you'll pick up that reflection. Maybe not consciously, but it bothers you more than just that same amount of noise just coming from one side. So we put more damping into the car so that sounds do get in, damp out quickly, which should be good for recording.
That should be.
right, absolutely.
It's like having built-in baffling.
Right. Yeah. Exactly.
And we've also worked really a lot on isolation from outside noises, so you don't hear the car next to you so much. And that we're trying to strike a balance, because if you isolate too much, you don't. Well, practical reasons you can't hear sirens, but also on a more subtle level, you don't feel connected to what you're doing.
Feel alone.
Yeah.
And you feel like you're not really controlling the car. You're driving a video game. Like you don't feel. We want
It's
to
like
feel
in your
the road,
headphones,
feel the
like
road,
you don't really know what's going on.
just
Yeah.
enough to feel connected and not enough to be annoyed. And it's the same with outside noises. Like you want to know that car is there, but you don't want to know exactly what's wrong with his brakes. Right?
Has that changed over time? Like what drivers prefer as far as like the isolation?
I don't know if I think there's people's baseline perceptions always change based on what their experience is. So as cars get quieter, maybe their expectations get more severe. That's definitely true. But our focus on this area is recent enough that we don't have a long history of looking at that.
Yeah.
One of the kind of trick ways that we improve the noise, outside noise isolation in this car, and improve the audio quality of the car was taking the big speakers out of the doors.
Yep.
Everyone has their
passage.
in the door, right? Because that's where you have enough room for it.
Yeah.
That's a really inefficient place for a driver. In terms of the space of the car, it's driving the sounding now volume in the wrong spot, and it also is a noise path from the outside, right? So we moved them up into under the dash, sort of in the corner of the room. Anytime you corner load a speaker, the sound quality is a lot better, right?
Yeah.
So it's a much more efficient way to get sound in the car, so we don't have to put as much power in to get a better sound quality at the ears. But also lets us seal off those doors. This is something I think everybody understood should be done. It's incredibly hard to do because the corners of the interior are actually really critical crash structure.
Yeah.
And there's a lot of other departments vying for real estate there, right? Because if you crash into something, the load from the bumper goes into the frame rails, which go right back into that corner of the car, and that's where the load has to stop crumpling things. You want everything in front of the windshield to crumple, and everything inside not to. And so that's a really strong structural corner. So normally, you develop a car, you develop a crash structure first, and then everybody gets to work on afterwards. And we had to get this concept of trying to move the speakers up into the corners before we started the platform development. To say, hey, crash guys, give us space for this speaker while you're doing that. Build that concept in, right? And so it was really sort of a big accomplishment for us to pull off logistically. I guess one of the things that Mazda is a tiny car company, our cars are the same size as everybody else, but the number of them that we build and the number of people that we have to put them together is quite small compared to most of the industry, which means that all of our engineering teams are mostly in one place, and they're right next. The main factory is right there too. So the manufacturing, the body structure design, the audio guys, they're all together. They're all eating lunch at the same time. It's a lot easier for cooperation like that to happen than it is in a big multinational company where stuff's being done in different countries and different languages all over the place.
I've never thought about how much computerization can help you guys change the feel of a ride. Do you know when, as an industry or as a company, you guys realized how much you embrace that?
Well, it's sort of been a slow process, and I think a lot of the cars controlled by computers now, of course. But being able to really take advantage of that and use it I think our purposes are different than a lot of car companies. So there are a lot of companies trying to do vehicle dynamics tricks. There's some others that when you turn in, they'll grab a brake and pull the car into a corner from one side or something like that. But I think what makes ours different is the level of subtlety and kind of what we're going for, rather than bigger performance numbers or go around the corner faster, is this feel, this very subtle feel that's kind of almost subconscious. And that that takes really fast computers. Like we've had this idea for the G-Vector control. We were working on it 7 or 8 years, I think. But our hardware wasn't fast enough. Like conceptually, we knew what we needed to do, but we couldn't communicate through the CAN bus of the car fast enough and get the engine to respond fast enough to actually make it feel natural. So for us, that particular level of integration couldn't happen until this generation of car. The computers finally caught up to being able to do
the
it.
ideation.
Yeah.
Thank you.
Yeah.
Yeah, thank you. Yeah, yeah.
Great. Thanks for taking the time.
This is awesome.
Right.
Thanks.
Yeah.